Hey, this is the second half of the review for your pre-calculus exam next week. This is going to cover arithmetic series, finite and infinite geometric series as well. So the difference with these ones is that now we're looking at the sum of, some number to some other number using a specific uh, function or expression. So I chose number 19 just because, and I'm going to go ahead and just kind of go over this little formula here. So n represents the number of terms. So in this one, we have from 1 through 20. And a quick way to calculate that would be our upper number minus the lower number, and then just adding 1. So in this problem, I'm going to do this as I go. In this problem, that would be n is equal to 20, because that's our top number, minus I is equal to 1, so minus 1 plus 1, which just gives us, let's see, those are out, so 20. So n is just going to be equal to 20 in this problem. Then the formula asks us to find a sub 1 and a sub n, and then to divide it by 2. So these are the ones that we do have to calculate, okay? So before, with the sequences, we already kind of knew what they were just by looking at the pattern or finding it using the formula. So now what we're going to do is we're going to plug in our first term, which would give us the answer for a sub 1. So a sub 1 is going to be 8 times 1 minus 10. And I'm just getting that from right here. Okay, this part right here. So when I calculate this gives me, let's see, 8 minus 10 is going to give me negative 2. Okay, so that is a sub 1. A sub n depends on the top number. So in this case, I'm going to look at the 20 that I have up here. Okay, so I'm going to use 20 to find a sub n. So a of 20 is going to be 8 times 20 minus 10, which is the same as, let's see, 8 times 20 is 160, and 160 minus 10 is 150. And that's it. So for these ones, you do have to find a sub 1, a sub n, and you do that through using the expression here next to our notation, okay? Anyway, so from there, I just plug everything in and calculate it. I'm going to go ahead and scroll down a little bit. So in this problem, S of n would be equal to 20 times, let's see, a sub 1 came out to negative 2, so negative 2 plus 150, okay, all over 2. And I'm just using the formula right here. So again, using our order of operations, I would go ahead and take care of the inside first. So this, I'm going to kind of do a few shortcuts here. So this part right here would be the same as 148, okay, which means that I have here 20 times 148 divided by 2. I can go ahead and either multiply and divide by 2, or I can also simplify here. I'm going to simplify because I think it's a little easier. 20 divided by 2 is going to give me 10, which leaves me with 10 times 148, which is 1480 or 1480. So that means that the sum of this particular expression here from 1 through 20 is 1480, 1480, and that's our answer for this one. Okay, I'm going to go ahead and move over to another example. I believe this one should be a geometric one. Yes, it is, number 26. So for a geometric series, we have the formula is a little bit different, actually quite a bit different. This is for a finite series, which means that the series doesn't go on forever. It ends at a certain number according to what's written up here. So this one uses a sub 1 again. It also uses R. Remember, R stands for the common ratio, and it uses n, which is the same as before, the upper minus the lower number, and then you just add 1. Okay, so luckily for us, this one is actually not that bad because a sub 1 is given to us right here. It's our first term. Okay, um, so a sub 1 is going to be equal to -2. N in this case, let's see, is going to be, let's calculate that real quick. So n is going to be the top number, so 8 minus the lower number, so -1 plus 1, which is just 8. So there are a total of 8 terms in this series, okay? And R, we have to actually, no, we don't have to calculate. So R is the common ratio. So if you remember from geometric sequences, we did that by dividing the second term by the first term, and then we raised it to a power when we plugged it into the formula. Well, luckily for us, this formula is already here, already done for us. So -5 is our R, okay? So we just plug everything in. Let's go ahead and do that. So in this case, S of n is going to be equal to a sub 1, so -2, a times, let's set this up, 1 minus r, our r is -5. I'm going to go ahead and put that in parentheses, to the power of n. Let's see, our n was equal to 8, okay? So to the power of 8 over 1 minus r again. So these problems are actually not that bad. I think the hardest thing that I've seen with my students is that they don't know how to, from here they don't know what to do. If you don't have a fancy calculator, you really do have to know your order of operations. So we're going to go ahead and work with that. Okay. Let's go ahead and I'm going to do several steps for this one. We have -2. That one stays out there. Okay. Times this huge fraction. So in this fraction, we can work with the top and with the bottom. I'm going to go ahead and calculate, let me see. I'm going to calculate this part first because I see that there's an exponent and I should probably figure out what that is. So -5 to the 8th power is the same as -5 times -5 times -5 8 times, which is a really, really, well, not too big of a number, but it's pretty big, okay? So this one comes out to 390,625. Actually, let me make some more space there. So 390,625, okay? And we still have, so this right here is this. We still have that 1 in front of it, so 1 minus all that, okay? The bottom I can also work with because I can see that this is just a simple subtraction. So those two minuses turn into a positive. So I actually have 1 plus 5, which is 6, okay? From here, I'm going to go ahead and subtract now. I'm going to subtract 1 minus all this. Okay, so that gives me my -2 is still there. So -2 is still in front. And 1 minus all of that is just going to give me negative uh, 396.24. Okay, just subtract 1. So negative 390,624. Okay, divided by 6. Okay, from here you can do a couple things. You can either multiply the -2, so you can do it this way, and then divide by 6. Or you can simplify the -2 and the 6, which is what I'm going to do because I just think it's easier. So this would be negative 390,624 divided by 3 because -2, 6, so this, if I divide this by 2 and divide this by 2, I get 1 over 3, so there's my 3 right there, okay? And then finally, I just divide by 3, and if you go ahead and do that, you should end up with, let's see, what did I get here? Negative 130,806, I believe. And yeah, that's pretty much the answer. Okay, so these ones are, again, they're not that bad. They just kind of, they take up a lot of room, I guess, and they are quite a few steps. Okay. All right. So moving on to another example, just to kind of give you a heads up on the next section, you did not get to practice this one as much as we would have liked. So because of that, we are giving you quite a few problems for that. Um, So just kind of bear with me. I am going to do 4 examples for that one, just to give you a decent amount of exposure to that, okay, to those type of problems. Oh, and you know what, guys? I made one mistake here. I just realized, looking at my math here, this should be a 2. So 130,208, not 6, because 24 divided by 3 is 8, not 6. Just make sure you check with your calculator when you're getting these numbers, because if you try to do everything mental like me, you might make a mistake here and there. Okay. All right, so let's do these last problems now. Either are 4 of them, and I'm going to do them relatively quickly, but still detailed. So these last 4 problems are, I believe, 4 of the entire section of your handout. Um, we're going to be using the formula for infinite geometric series. So this one, if you see up here, we have this little infinity symbol right here, okay, which means infinite. So these ones, when you add them up, they either diverge, which means that they go on forever and there's not really a sum because it just gets bigger and bigger. Um, or it converges to a number. So converges means it gets really, really close to, let's say, I don't know, 5 or something. It gets really close to that number. So even if you keep adding terms to it, it's just going to be adding a very, very tiny decimal. Okay. So the way to figure out which one we're going to be using is we look at our common ratio. So the ratio, remember that's the R, is going to be this term right here. So this is our ratio, our common ratio. And we're going to look at that and see which one it classifies into. So we have 2 options. We have option A, where the absolute value of r is greater than 1. If this happens, then that means that the sum will diverge, and there is no sum. It doesn't exist. It goes on forever. Otherwise, so if our absolute value is not greater than 1, then we're going to be using this formula. S of n is equal to a sub 1 divided by 1 minus r. Okay, so the first thing we need to do is look at our R. So R in this case is 1/3. Okay, so if I take the absolute value of 1/3, I can see that this is equal to, well, still 1/3, it's still positive 1/3. And 1/3 is not greater than 1. So that means that it's not going to be option A, it's going to be option B. So option B tells us that we need to find a sub 1. So a sub 1, remember, is just the first term. So there it is, a sub 1. And we already have r. R is 1/3. So I'm just going to plug everything in. So S of n is equal to a sub 1, which is our 2, okay, divided by 1 minus r. And our r is 1/3. Okay, so from here, this is a little bit of fraction work, nothing too crazy though. We have the 2 on top still. We have 1 minus a third. So 1 minus a third is going to be 2/3, because if you think about it, take away a third of a pizza, you're left with 2/3 of a pizza. So this is now 2/3, okay? And then we use the same thing we did earlier. We did that KFC. in the first video. So we're going to keep the top one, so it'd be 2, flip this one, so 3 over 2, and change the division to multiplication. If it really bothers you, you can put this over 1, okay? So from here, you can see that the 2's are equal to 1 because 2 over 2 is equal to 1. So we're just left with 3 over 1, or more simply, 3. So the sum of this infinite geometric series is just 3. Moving on to the next one. So this is number 28. We're going to be using the same concept. So remember, here's the formula. Make sure you have it written down. So we first want to check our common ratios. So let's go ahead and do that. Keep my colors consistent. So our R is going to be equal to 0.7 in this one. Okay, so if we take the absolute value of that, well, it's still going to be positive, which is 0.7. And 0.7 is not greater than 1. It's actually less than 1. So that means we're going to be using option B, which is that formula again. So S of n, I'm going to write it real quickly here, is equal to a sub 1 divided by 1 minus r. Okay, so in this problem, a sub 1 is going to be again our first term. So there it is, 6. And r is 0.7. R is this one right here. So let's plug everything in. So S of n is equal to 6 divided by 1 minus 0.7. And we can do this in our head. We don't need a calculator unless you messed up like I did earlier. So the 6 stays the same on top. So I'm going to leave it like that. 1 minus 0.7 is the same as 0.3. Okay, because it's like saying take away 70 cents from a dollar. And if we divide 6 by 0.3, well, I know that 6 divided by 3 is 2, but because of that decimal, you have to move it over 1, so it's 20. And that is our sum of this infinite geometric series. You can check my work if you'd like in a calculator. Okay, next one is 29, and I believe 30, and I think that's it. So we're almost done. So here's 29. We're doing the same thing. I'm going to go ahead and find my r first. So r is equal to, in this one, -4. And if I take the absolute value of -4, I end up with 4, which is greater than 1. So let's go back and take a look at what happens if that happens. So really quickly, if you look here at our option A, so right here, okay, a horrible star, but right there. If it is greater than 1, that means that the series is going to diverge. That means that there's no sum because the numbers are just going to go on and on and on and on forever and ever. So we can't really add that up. It's just not possible. So luckily for us, we have no work at all. Well, just a statement maybe. So this series, so since the absolute value of r is greater than 1, there is no sum. The series diverges. And that's it for this one. We don't have to show any more work because this is our work. See, didn't take that long. Last problem, number 30. So we're going to look at our r first. So r is equal to 1 over 4. Remember, it's just this number right here that's raised to a power. And if we take the absolute value of 1 over 4, we get 1 over 4, which is not greater than 1. So that means, like the other two problems, we have to go ahead and do some work for this one. So we need a sub 1. We need r, which is that 1 over 4. And we need our formula. So our formula is S of n is equal to a sub 1 divided by 1 minus r. Okay, so I'm just going to plug everything in. So let's do that. We can do it over here. So S of n is equal to, our ace of 1 will be 64 in this one, okay, divided by 1 minus 1/4. So just like the problem before, I'm going to leave the 64 on top. And if I take away a fourth from 1, I'm left with 3/4. Think of it like quarters. You take away a quarter, you're left with 3/4. Okay. Just like before, we're going to use our keep flip change. So 64 times 4 over 3. And in this one, we really can't simplify like we've been doing. So we're going to actually have to multiply. So we're going to multiply 64 times 4 and then see if that's divisible by 3. So let me see. I don't know if I can do that in my head or not. 64 times 4. So I'm getting 256, I believe. Okay, and then divided by 3. And I don't think that's divisible by 3. Let me double check that one. No. So that one gives me a decimal. So I'm going to leave it as this just because it's more precise this way. And that's it. So in this case, our sum, our geometric of this infinite geometric series is going to be 256 thirds, or 256 over 3. And I believe that that is it. That is it. So if you have any further questions, please feel free to contact your teacher and let us know if you need any help. Thanks for watching.